The fourth industrial revolution is here, but it has yet to reach its full potential. Smart manufacturing technologies provide companies with zettabytes of data that lack context and standardization. Making this data useful for IT systems and business users is a time-consuming and labor-intensive task. Industry 4.0 is failing to scale without a data infrastructure solution. Enter Industrial Data Ops, a trusted approach to data integration and security that helps improve data quality and reduce data preparation time for analytics and AI applications. HighByte Intelligence Hub is a proven industrial data ops solution built to help the OT model, transform, and stream plant floor data to IT systems. HighByte Intelligence Hub is secure, edge-native, low-code, and easy to use and maintain. Connect to inputs and publish to outputs with a few clicks and zero scripting. Design models that standardize and contextualize data, and securely configure real-time data pipelines to consuming applications running at the edge, on premises, and in the cloud. Transform real data into information that's useful, secure, and scalable with HighByte. Get your free trial and create your first data pipeline in less than 10 minutes.
Please welcome to the stage, HighByte.
I love that song. Hopefully at some point we'll be able to get more of it. Yeah, thanks, Jeff. Like Jeff said, we had no idea what he was going to say about us, and we also had no idea what that video was. But it's pretty exciting. But instead of watching the video, I think you're going to hear it live. So let's move on with the show. So today, we're going to talk about UNS, and what I call the modern UNS. UNS has changed, it's evolved over the last few years, so I think it's important to kind of touch base on what it is. And really, it's about taking chaotic data and turning it into real business value, and of course, preparing for AI. So, we just heard a long talk from Walker and Dylan about UNS, but I felt it was important to kind of ground us in why are we really doing this? Because like Walker said, there's multiple levels of people in their experience here. But, we're moving from pre-UNS, we had monolithic systems, we had point-to-point integrations. If you want to get data, you go and you log into that. In fact, we talk with a lot of operators, they say, oh yeah, I've got 20 different logins to 20 different systems, and when I want to get this data, I have to screenshot it out of this system, and then I want to write it down on my notebook and go into another one, and it just doesn't scale. With the UNS, we have open access to data. Data is now available. It's freely available. It's freely available for us to download into Excel spreadsheets. It's freely available for us to run AI agents to get access to that data. And that's what's critical for companies to drive their business. So, as Jeff said, HighByte has been doing this for 6-8 years. We've been implementing UNSs. We've been implementing it with these customers. This is just a small subset of our customer base. But I think this list is really important because it shows the scale and the scope of the customers that are implementing this today and are using this to drive their business today. We see a wide range of industrial or manufacturing verticals, from automotive to industrial products to food and beverage, pharmaceutical, oil and gas, power utilities, even logistics and distribution. And these aren't just small companies, these are large global companies implementing the unified namespace across their enterprise. But I wanted to talk briefly, and you're going to see in our demo how the UNS has evolved. And Walker and Dylan kind of talked about this blue and red concept. Data is critical to the UNS, and we're starting to think about it as you have to put data products in the UNS. Okay, just like you as manufacturers of drugs, of cars, of airplanes, you name it, you produce products. You take raw materials, you run them through a manufacturing process, and those products have a designed outcome and a designed benefit for a customer. You have to think about data the same way. We're going to automate the curation of data, But think about data as a data product, and you want to put it into the UNS and put it into your, integrate it with your systems as a data product which is standardized, which is contextualized, which is ready to be used. We also see integrations being much more sophisticated. Instead of just publishing OPC tags or telemetry data into the UNS, we're integrating with lots of different systems. We're piecing data together to create these data products. We see access patterns changing. MQTT is a tremendous protocol, and Arlen's going to get an award because it has changed our industry. But MQTT is not the only way that you can get access to data, and sometimes it's not the best way. We need to run transactions. We need to move bulk data sets. We need to move imagery from the edge to the cloud. We need to expose data to AI agents. Well, they're using lots of different access patterns and different protocols. And finally, we need to distribute this and we need to govern this because as they talked about, it's not just having one UNS. It's too much data to have a single UNS. You have multiple UNSs, you have them at different levels. You need to have this and you need to govern them. And finally, we need to prepare for AI. So we're going to get in and we're going to look at Factory C. This is a pharmaceutical use case. We're working a lot with pharmaceutical companies right now. In fact, it's our fastest growing industrial vertical. So what we're going to see, we're going to build data products, batch records, asset records. We're going to integrate the systems. We're going to build pipelines where we're moving data. We're going to use APIs to access the MES. We're going to pull data and push data into a Pi historian over SDKs. We're going to move data to Snowflake, to Ignition. We're going to distribute this, and we're going to show you how you can have multiple plants, and then we're going to expose data and make it available for AI. Because AI can do two things. Number one, it can allow us to scale the system much better, much faster. As Walker said this morning, everyone wants MCP so that they can rapidly scale the solutions. Even casual users you're going to see are going to be able to utilize this system because they can interact with an agent. But it also is a huge consumer of data, and so we're going to see that. So with that, you don't want to just keep on listening to me. You want to see us put this in action. So I'm going to turn it over to Jeff Schroeder, and he's going to get the demo going.
All right, let's get started. So let's get a background on this pharma manufacturer. This is a biopharma startup, if you will. They're producing a therapeutic enzyme product.
It's wrong screen.
Can you switch to
the loud Jeff screen?
There you go.
I don't want you to see my stuff. That's at the end.
There we go. So this is a biopharma manufacturer. They're producing a therapeutic enzyme product. They're very low in terms of their digital maturity. Right now, it consists of about 4 assets. It's largely around this fermentation process that you see is the second process there. You can see that takes almost nearly a week to execute. So if you look at upstream and downstream, right, a lot of the critical aspects of execution are surrounded that bioreactor process there, and that also has implications down upstream through our supply chain and so forth. One thing that we quite liked about this particular UNS was when we came into the environment. Let me go ahead and connect here. That's some delay. This thing is like all reflective here. So we'll go ahead and hop in here. Great. One thing that we quite liked about this particular environment is how primitive the data was. Normally, when we come into these things, we're used to seeing in the other enterprises, we're used to seeing something kind of like this, right, where we saw already kind of contextualized data. So in other words, our manufacturing, our execution, and planning context was coalesced with our asset telemetry already. In most cases, when you walk into a factory, that's not going to be the case, right? These things are going to be silos, and if any cases, many times, that execution and planning context is non-existent, or it's barely a digital artifact. So typically, what you'll see is something much more primitive like this, like DCS tags, directly out of the process control realm. So looking into this thing, right, we clearly see that there's long batch execution. We also saw in between the execution, the runs of these things, there's a lot of dwelling times and idle in between there, very long changeovers. So right now, this plant is basically running on paper, right? You have tons of frontline personnel, engineers, technicians, et cetera, shuffling batch tickets up and down with these assets to basically execute their manufacturing. So while there's been a lot of excitement this week on, hey, I want to apply AI or I want to do very deep advanced analytics with my data, but if you have to focus on where's that Pareto effect today, where is the biggest gain for productivity right now? And a lot of that kind of comes down to just classic good old manufacturing execution. So to address this batch management problem, this manufacturer elected to implement Kerber PassX. Kerber PassX is a very popular MES, particularly in the pharma space. And what we elected to do here is not so much based off of, hey, we're going to take the direct digital equivalent of that manual batch execution process. So in other words, we're not going to have end users go to screens and type in things instead of writing them down on paper, but we're going to actually turn this into a digitally integrated batch management process. And that's done by building data services. In more advanced industries, particularly if you're making highly engineered products or if you're working in heavily regulated industries where there's like very strict quality requirements, the MES is much more of a conductor. If you're newer to MES, you're probably accustomed to MES kind of being a more passive node in the architecture. Yeah, it might work through a dispatch list of scheduled work orders, but largely, once you're running production, in many cases, it's merely just kind of collecting states and counts, if you will, and that enables downstream reporting. But in more advanced product manufacturing, the MES is much more of a conductor, and it's kind of having a conversation with the automation systems on here. So I'm going to we're going to focus on this batch setup example that we have here. And what we've done here is we've basically built APIs. So instead of the telemetry kind of fire and forget into the MES layer here, we're actually creating a data service that can be invoked by our MES to basically do this batch setup. So I'm going to show real quick with the magic of television, just because we're constrained on time. So this is an example of the front end of PassX, and right now it's setting up a batch. It's calling our endpoint and writing this down. So you can hear these are basically the classic kind of set points in batch execution that you would typically see in the environment. And now let's go ahead and walk through what we're seeing behind the scenes. So what just happened here is PassX called our product construct called the REST data server. It's basically an API. This sent a message, an XML document, basically. We took that, validated it, and then performed our writes down to the asset. So I'm going to hop into the environment and show what that actually looks like in practice. So this is the intelligence hub. This is where you engineer industrial data. So I'm going to first hop into this pipeline section here. I'm going to go to this batch setup. So as you saw in the video, I've already ran that command, and I'm just going to play back what we've already done in the past. So we have this function called pipeline replay. So pipeline is essentially where we sequentially process data, and it's how we move data within the platform. So what I'm doing is I'm replaying a message that's already came on there. So this trigger here is essentially was exposed to a server interface, and it could be called and sent messages through. So I'm going to expand this here, and we'll look at this replay. So we can see here, here's the header. MSI is the interface construct of PassX, if you will. But we can see here we have batch context. So instead of shuffling papers back and forth to our assets, we also have a collection of set points that we wrote to the asset. If you also look at the rest of this pipeline here, I have a bunch of error handling, right? So the first step what we're doing here is we're basically we're validating this data structure that it's accurate. We don't want to blindly write to our sensitive industrial automation and potentially damage our batch, right? So the first thing is we're using this model validation stage that we have here. This is basically saying, hey, does this meet the shape that we're expecting? The next step that we do here is we're then reshaping this data for automation. This is a great payload that we have here coming from our manufacturing execution system, but let's be honest, this data structure is not something you would see with typical PLC registers. So now what I've done is I've reshaped this data. And to show what that looks like, if I go into the environment here, and I go to this configure, effectively I'm just taking those incoming payloads and I'm reshaping the payload. So finally what we're doing is then we're writing this to the asset. And then if we get a success, and we have the success and failure here, we respond back to our MES and say, good, we're all okay to proceed with the batch. So we just got batch context. We just implemented batch management. What's next on the list? So the next step, what we're going to focus on is now that we have batch context to our telemetry data, it's actually useful for us to dive deeper into our manufacturing process. Because again, when we looked at earlier, right, this is pretty useless, this data, these primitives that we have here, if we don't have our batch context. So now we've digitally integrated our MES, a part of our manufacturing process. We can now apply batch context to it. So the first thing what I'm going to do here is I'm going to go to the modeling environment. And I'm going to go to this guy here. So I'm going to first look at this ferment sub model here. So here we have a couple of different sections here. We have our batch context. This originally came in from our API that we wrote directly down to our assets. We kind of broke this up into kind of different subgroups, right, about the asset. We can declare types. We can get much more rigorous with the data models and so forth. But the other thing that also shows we don't have to manually define data models. We can also import them. So there's been a lot of talk about SESME this week, as you know. We support OPC node sets, which is the technology that smart manufacturing profiles are declared with today. We also have JSON schema on the roadmap, and that should be shipping in about a month. So I'm into the environment here. Next thing, what I want to focus on is, now that I've modeled my data, I want to take a look at a couple of actually putting them to use. So in other words, instantiating the data model. So here I have, where's this guy that I'm looking for? TFF, there we go. So here what I've done is I've hydrated this data model. So it's very, very simple to hydrate these things. I go to this reference pane. I go ahead and pick up a data piece. So I have this TFF here. I can browse this, and it's simple. It's just a matter of drag and drop, right? The one thing that I also wanted to mention is that some of these assets don't have all the data available, and that's a very common case in the real world, right? So what I'm doing here is I'm actually deriving state by monitoring certain sensor and actuator values, and I'm basically doing some if-then logic, if you will, to determine if this thing is running or not. So the next part is, now that we've kind of modeled these different data sets, what we want to do now is organize these data sets. This is namespaces. So this is our construct for modeling for organizing data sets and designing the overall access patterns if we hear. What really was going on here is that when I open this up, this is essentially turning my entire factory into a giant JSON document. You might say, okay, that's kind of interesting, what can consume all of this at once, but the whole point of this here, right, is that I could elect to consume this all if I'm sending it to a flexible data target, like a data lake, or what I could do is I could pick off part of it, so I can read the entire thing or parts of it. And that's largely done by just simply using the smart query C. So you can see this from area has been modified. I could focus on this bioreactor asset. I could even introduce predicates on here. So in other words, we're not merely limited by querying just by asset hierarchy. We can query across asset hierarchies or by types, right? So now we've designed the UNS and we've queried our UNS. What can we do with it? So that ultimately is a function of what you want to do with the data. You're going to find that there's many different data applications and services. But here's a sample of things that we typically see among our customers. So the first example that we already did is we basically exposed the UNS as an API that could be invoked for our MES, right? We see lots of other types of solutions. We project the namespace into message brokers. We project the namespace into IoT platforms, historians, even data lakes with open table formats, right? And what we mean by project is we don't mean merely just delivering data to the target system. We also mean is actually synchronizing the schema. So that is creating schema in the target system. So in other words, a lot of us are familiar with Ignition at this conference, right? Imagine your gateway is blank and you don't have a tag provider on there. That means that as new assets, as new use cases, as new data points come up, as things change in your environment, you can project into that system, and that tag provider is seamlessly built out. This would take a long time for us to go through all these, but the one I'm going to focus on that I think is most relevant for pharma manufacturers, as well as, and also I think it's one of the more challenging ones here, is Aviva Pi system, which is kind of the big historian that you typically see at the top end of the pharma market. So what I'm going to do now is hop in the Intelligence Hub, and we're going to effectively query this namespace. So what I've done here is I'm going to go to this second example here. And what I'm doing is I'm running a smart query here. Don't be overwhelmed by all the different nodes that I have here. What I'm really doing is I'm just publishing to a lot of things, so you can all see those on the screens outside there. But I promise I'm not actually modeling data. What I'm really doing here is I've just queried that same giant JSON document that I've done. If you see these identifiers that I have here, I have names, I have paths, and so forth, right? So what I'm doing is that I'm projecting these to target systems. So the only one case here is this data lake is we're slowing the publish rate down because we don't need to deliver it quickly. But what I really want to emphasize here is this Aviva Pi system. I have this write new stage here, and you can see that I have this create flag on. That allows us to project the namespace into a target system. So in practice, what this means, though, is now that I sent this in here, this Aviva Pi system was blank previously, but to really emphasize what we just did here, I'm going to go back to namespaces and expand this, right? Our tree here. If you look at here, it follows this hierarchy, 3-point therapeutics, Boston, manufacturing, and so forth. We can see that directly projected here. So as we introduce new assets, as things evolve in our environment, our namespaces are continuously synchronized. So that's what we mean by projecting to where data needs to go, and so we're not stuck having to remodel our data. absent data ops, you would effectively have to be stuck building disparate sets of pipelines and effectively remodeling data. So even these might be semantically equivalent, they're subtly different in terms of how they might consume hierarchy and so forth. So the last thing that I wanted to quickly touch upon is this concept of multiple data models. I think a lot of people, when they think about UNS, they're often fixated on this concept of publishing data in, but they don't think about, well, what's consuming that, right? And also, what does that mean in day n+1? How do things evolve over time? So we're going to just introduce a new scenario here as the final case. So let's suppose that we've done our batch management, we solved that problem, we're now historizing our process. The next thing is condition-based maintenance. And so we have a team that says from this plant that I want to implement MaintainX, right? One thing that we have to think about is what is MaintainX, right? It's a CMS, it's an EAM, right? It probably does not have a construct in there to store batch records, right? It's not really related to pharma, right? It's related to assets. So the concept that we're not going to just dump a giant UNS to a specific application, right? What we need to do is effectively reshape our data. So this is a concept that I think sometimes trips people up, but what we can do with a UNS is, let's suppose that we want to use this meters endpoint within MaintainX. We don't have to start from square one and build fresh asset models according to the shape of the endpoints that MaintainX expects. We can actually start from the UNS, from our assets, and effectively reshape the data. So think of that as multiple levels of data models. I have asset data models, and then I have use case data models that align with the target system. And so in the power of 20 seconds, real quick, because I'm just running right out of time, I'll show what this looks like. So here I'm browsing the fabulous MaintainX API here. You can see here that this data shape is basically an array, and each element represents a meter reading. And I think if you can see up here, they say, we strongly recommend that you use this and you don't slam it. So they're saying, hey, make sure that you buffer this data. So to show that this is in fact real, right, I'm gonna go to this last pipeline here to wrap things up, and I'm gonna show what's going on here. So what I've done here is, instead of me starting from scratch with those raw tags and having to map this data structure, what I did is I started with this MaintainX data model here. So if you remember, this data shape looks familiar, meter ID, value, and read date, and so forth. But instead of going back from the fresh tags, what I started with is I queried my UNS asset models. I picked out what is relevant to my use case. I cross-referenced those with the meter IDs inside of MaintainX. I reshaped the data, I buffered it so I'm not slamming the endpoint, and then I'm sending that to MaintainX. And so the end result here is we were able to quickly onboard a use case very, very quickly. I'm running just that time, so to really just wrap up what we've done here, we have batch execution, we have contextualized historical data for observing the manufacturing process, and we've done condition-based maintenance. This plant is very, very productive, it's very profitable, it's apt for expansion. Let's explore what it might look like in an enterprise context.
Awesome. Thanks, Jeff. Last year at ProveIt, I got 1 minute to show AI-generated mapping of instances. This year, I get 9. So we're gonna go wild. If you could switch to my screen. Awesome. So Jeff is our brilliant plant engineer at the site in Boston. He just rolled this all out, and now I'm the DevOps guy that's got to roll it out to 2 other sites. I'm gonna cut this part of the demo a little short because Walker pretty much said it, what I'm gonna do on stage in terms of Portainer, in terms of Docker Compose, in terms of Git. I think the important message is HighByte is DevOps friendly. We're IT friendly, right? We're friends with your IT department. And we've been this the whole way along. So my job, I'm gonna put on my DevOps engineer hat. I need to spin up 2 more instances, and that's Seattle and Dallas, and then we'll talk about the central one next. So I'm gonna use GitHub, OpenTelemetry, and Portainer. The most important thing I need to steal, sorry Jeff, is his configuration, right? So if you look up here, up in GitHub, which you've seen this throughout the show a few times, we have Jeff's entire configuration in JSON format, which you've always supported, and that's up in a repository that I can pull from. The next thing I'm gonna use is the simplest way to do this, which Walker mentioned, which is Docker Compose. There's other technologies to do this, but if you're just getting started, this is the way to do it. Oh no.
Did you lose power?
My PC just rebooted.
Power?
Yeah, I think it's a power issue. Well, that's exciting.
Can you use Jeff's?
Jeff, can you log me into do you have access to the central one?
No, do you have URL?
3.4 dot.
Here, let's do this.
Can we get to, I just need to get to the central HighByte. Does anybody know the IP off their head? Oh no. Oh. Yeah, we might be We might have to do it in the workshop. That's a huge bummer. It's a lot of prep. Okay, so I'm not going to be able to show it. You'll have to come to the workshop to see it. But essentially, what I was going to show you is we can use Docker Compose to deploy those sites. And then, unfortunately, I don't have the IP to log into my EC2 instance to show you the setup. But we will show it tomorrow with Sesame. Yeah. Oh, we're booting up. I got 6 minutes. Battery is low. Yeah, we're sorry,
Just
guys.
went out again.
What's that?
Just went out again.
Five minutes longer. I jinxed myself, right? I'm like, I got 1 minute, and then kaboom. John's gonna kill me because this laptop is literally 5 or 6 years old, and he's constantly getting on me to upgrade it. And I'm like, I have an iPhone. I'm a CTO of a manufacturer. I have an iPhone with a button on it still. Like I will use technology that works. Maybe this is the time, John. We can still recover that. I'll log in and we'll get back on the central instance, and I'll skip the DevOps thing. It's cool. As industrial data ops, you definitely need to be able to do that. You need to be IT friendly. The truth is, it's not as easy as just spinning up here we go. It's not as easy as spinning up a bunch of containers at the sites. Let's just get there. Because the truth is, your sites are all different, right? So I can spin up infrastructure and deploy HighByte at the sites, but your challenge is contextualizing all the data at Dallas and Seattle, because those systems and that plan is different than Boston. And the truth is, instead of pulling a single GitHub repo, what you ultimately do is you have GitHub repos that have the specific configuration for those sites. You pull down like the master configuration for models, for example, and the site configuration, and deploy that. Okay. Everybody cross your fingers. I can't believe this came back so fast. This is great. I'm going to skip ahead, and I'm going to show you a new feature called Central Data. So let's assume I did that. I deployed that. We're out on Portainer. I've got multiple HighBytes. I've got it connected to OpenTelemetry. So as DevOps, I can monitor the logs, CPU utilization. I'm happy on the IT side. Now my job is, as an engineer, I've got to go.
You've got no power.
What's that? I don't know what's going on. Okay, I'm just going to walk you through it. We'll talk through it, and I got 4 minutes. It's too bad. Essentially, those sites are going to connect to a central HighByte now. In that central HighByte, that namespace feature that Jeff was showing you, we can actually move data through that feature now. So what I was going to show you is I can now create a central namespace that's composed of all those remote sites that I've already contextualized data for. John's going to try to swap out my power here. The real key point there is once I've done that, I can then create a pipeline that goes and reaches to all those remote sites and says, give me everything of this type of asset, and then move that to Snowflake. What that's doing is it's sending communication out to the sites, creating a subscription for anything of that asset type, pulling it through HighByte, and then sending it through Snowflake to Central. So the message there is if I've done the job to contextualize data locally, okay, I can then use that in Central to make my pipelines and configuration much easier. Composable, it's federated data ops, right? So if I've done the work to contextualize the local sites, now I can make it really easy to be able to move that data through centrally and create really, so that the use case was like, hey, we got the cell count machine at all the remote sites. Our challenge is that cell count machine is malfunctioning. We need to share some data with the OEM. Now that we've modeled that contextually, Jeff's got this up. So I can pull that now through the sites and then run that through Snowflake and then share that Snowflake table with the OEM, right? But I can do that because we've done the work to contextualize the data locally. With 2 minutes and 30 seconds. The last one and this is the bummer, this is the coolest one. I was gonna show you one around, you've seen a bunch of AI chatbots. What I'm really excited about is we actually have customers starting to use AI chatbots. So I want to be real with you around like where the industry actually is, right? So they're starting to create custom MCP tooling into industrial infrastructure like Pi, like Jeff had shown, and they're starting to get value out of the data. That's kind of where industry is right now. Unless anybody, I don't think anybody's using agentic AI in manufacturing. They're playing with the concept, but there is nothing getting rolled out in production. Everyone's concerned about it's not just reading data, advisory, but also control. The key to agentic AI is in HighByte, we have MCP services, so we're very focused on providing custom tools, very tailored tools to control the context of the agent. The workflow I was going to show you, and we'll do it in the workshop, so I guess come there. Oh, it's on Thursday. Or John, you help me out? I think I can actually show this one with a minute left. Isn't that ironic? I got a minute last year. And this year I got a new laptop and another minute.
Okay.
Let's see if this logs in. I'll show you. The workflow is basically like, hey, the operators are not going to be logging into Claude code and like typing and communicating with LLMs in the factory floor. That's like it's eventually going to happen, but we know as an industry, we're not going to rip and replace the systems that are there. The fact is, we have context on the edge, we have context in the cloud. We need to create pipelines that move that data.
You can eat into some of the Q&A. Just keep going.
Sounds like I need a new power supply. So I'll log you in and show you this one. And it is the funniest part of my demo is actually going to be this, which is the world's worst ignition. I apologize to Travis and Kobe for this ignition screen you're about to see, because this is what I built. But ignition can obviously do much better. So the pipeline I was going to show you is this one. And essentially think of this as I've got data at the edge and ignition. So what this pipeline is going to do is it turns on, it goes and reads ignition. It's going to pass some data to Snowflake as soon as I wire this up. This is my very sad perspective screen, okay? But what I need to do is I need to deliver AI capabilities to this screen that the operator already knows how to use, right? He's not going to use a chat. They're not going to use a chatbot. I need to deliver it here. So what this pipeline is doing is it's reading the data from ignition. It's going to pass it up to Snowflake and then send it back out to ignition after it does some analysis. Now, if we logged into Snowflake, what we would see is in Snowflake, we use Cortex on the raw data to build up a semantic model of the fermentation process. So it's this pipeline is passing a snapshot up with some additional context, using that context in Snowflake, and then delivering back a result that says, are we in normal range, abnormal, critical, and then we're writing that back to the existing system and showing it here. The point of this is that we need to deliver AI capabilities to the tools that we have in the factory already. The chatbot stuff, all that, it's really cool, right? But we know the limitations. We're not going to rip and replace. And this is just an example of data ops as the data flow both in and out of the factory. Let me just, now that we got it, amazing. I'll just show you one more thing. This is the central data piece. So if you go here, you can see the Dallas, Boston, and Seattle sites are all connected to the central hub. That's what we're in now. And this is the really new, we call this central data. We need to better market it. We're an engineering organization, if you can't tell. I don't know how to market and name stuff. But I can drill in now to any of the local namespaces that Jeff had built out, right? And I can build up a central namespace. And then I'm literally, like Jeff was showing before, assuming that one of these fires up, I can drag and drop parts of this namespace in to build a central namespace. Once I have the central namespace, when I hit test read, this is going out over the 3 sites and pulling all the data together. And then, so once I have this, as that engineer that needs to solve the OEM problem, I can jump into this simple pipeline. And what this is doing is it's creating subscription on the central namespace saying, give me everything of type cell count. So that's the model that Jeff had defined that we've put across the plants, and then write that out to Snowflake in that table. So if we've done the work to contextualize our factories at the edge, define that factory API, obviously things become a lot easier. The very last thing, because I need a pitch for Sesame, because I'm heavily involved in i3X, and I would shoot myself, I would be very upset if I didn't show this. You can also now, i3X is a standard you're going to be hearing about. What I'm going to launch is an i3X client, connect to that same central, and what you're going to see is that same view of the entire organization. And from that client now, through an open standard, I can create those subscriptions, discover the data models, and move data, assuming this guy pops up. Oh, we're doing great on time. So let me just show you this last part, and then we'll cut for questions. And I apologize for the laptop issue. John, I will order a new laptop today. This is the sign. Okay, so this is i3X. You're going to see this in the Sesame presentation on Thursday. The spec is not ready, right? A lot of this is still early stuff, but you'll see a lot of vendors support this. I call this the API for UNS. We need this as an industry. So what I'm going to do is I'm going to connect into HighByte. What you'll see up here on the top right is all the model definitions out the sites that Jeff had defined. So I have the JSON schema. I can discover the data model through this. I can also browse through this. That same hierarchy you saw in my central namespace is exposed over an open standard. So you'll see Siemens Mendex will be here in the Sesame demo to show a client perspective of using this, even across sites that we've modeled. And then I can drill into any one of these sites, see the same data, and also create a subscription. You see the data here in the middle. It's actually reading the data. I can create a subscription and start to stream that data. So I'm pretty bullish on this. I think we need this as a standard. It doesn't negate anything we're doing with UNS or MQTT, but it is an interoperability layer that I think is going to provide best-of-breed solutions in the market and help us all mature around data modeling and contextualization. Thank you for letting me go over just a little bit. I apologize for the laptop issue, but hopefully that was informative.
Awesome. Yes, we gave a couple extra minutes for the technical side, so we're going to restart the timer for the Q&A. We have the Slido up there, so feel free to ask your questions, and they'll kind of show up if you guys want to stand over here. So I'll kind of kick it off, because I'm sure several people are wondering this who may not know you as intimately, but DevOps, data ops, data platforms, where do you see yourself kind of fitting in this landscape?
Yeah, I can take a shot, and then John. So I define industrial data ops as a factory API, and I say that because we are that layer on the factory that helps you standardize the data coming in and out, and the data flows coming in and out, and deal with the complexity of the fact that every factory has different systems and different technology. So what Jeff showed, and we roll those plants out, sure, they're showing the same interface like an API would, but how they're actually wired in, the systems they're wired in is different. So I think that's key. The other key piece is industrial data ops is just that layer. We are not storing, contextualizing, modeling, analyzing data for ourselves, right? We're doing it for other consumers, Maintenance, Aviva Pi, the systems we showed you, and that's different. We don't want to replicate functionality you already have in the factory, because you probably already have too much tech there, right? You just need that layer of interoperability.
It would take seconds, I knew it. Why HighByte over Litmus or Maestro Hub? That's why I was trying to precede the question. Go ahead.
I guess one way to think about it is HighByte is razor focused on engineering industrial data. When I think of solutions like Litmus, I think of it's broadly it's an edge compute platform with an emphasis on hosting IoT services, right? There's device drivers, they feed into a NATS broker. There's Golang and Tango scripts. There's Node-RED, Grafana, InfluxDB. So a lot of those things are device connectivity, storing data, visualizing data, analyzing data. For the type of organizations that we work with, they're not necessarily interested in those things because they have other solutions in place. We're razor focused on the area of industrial data ops, that is engineering industrial data. So I think a lot of other solutions tend to focus on more of, we're starting with the data source and trying to provide access to different systems, whereas the type of organizations that we work with, they tend to focus on the data target, right? How does data need to be consumed? What is the access pattern? Work backwards from that to determine how we engineer data forward.
Yeah, I think just to build on that, as Jeff said, they're kind of full stack solutions. We very much see ourselves as a horizontal solution. But it's not just telemetry data. Like Litmus is also, they've got tons of drivers. We've heard about them. You can go down and see them. Really focused on that telemetry data. What you saw here was we're really focused on, sure, get the telemetry data, whether it's through Ignition or through OPC or through MQTT. But there's also the REST APIs. There's the SQL databases. There's the files on the system of the inspection equipment. How do we get access to that data? It's taking a much broader view of what industrial data is and making that data accessible and being able to combine that data with the telemetry data, being able to use that as context and being able to deliver it to wherever it needs to go. So we're very focused on delivering to the cloud. We're very focused on delivering data to the operational systems, pulling data out of the cloud and delivering it locally. So, it's very much that horizontal middleware for industrial operators to move data and curate and contextualize your data.
Awesome. I saw a question on there earlier, but it missed that a lot of you guys liked on the i3X. Is that something we can play with?
Yeah, so that's up in GitHub. You can actually download that client that I showed you. It's open source through Sesame. A bunch of us contribute to it, so that is kind of the de facto client now. You can grab that now. Our next release in March will have an i3x server. It'll be an alpha, right, because the spec isn't released yet, so don't go put it in production. Things will change, but that is a way to get introduced to and start playing with the concept of i3x.
Yep, and I think Sesame has a session tomorrow.
Yeah, and we'll be on Ignition and a bunch of others, yeah.
Yes. As a smaller manufacturer, 2 sites, I see HighByte and go, that's a great tool, but it's far more than we need or could use. What is your reaction?
So I think you have to consider how digitally mature you are. We have some very small customers, or customers with very small businesses, single site, a couple of sites, but they're highly digital mature. They're companies that are very focused on how do I get that data out? How do I utilize it? They're already moving the data to Snowflake. They're already moving the data to the cloud. They're already running AI and thinking about how can I do all that. If that's your plan, then I don't think we're overkill. On the other hand, if you're a small company, you're a machine shop, nothing is connected today, you just want to get a dashboard to see your data, you're right. There's many other solutions downstairs. You could go to Ignition, you could go to Machine Metrics, you can go to other people that are downstairs that can provide you with that level of data and that level of visibility. So, you know, it's not so much the size, it's much more the digital maturity and the digital sophistication of their IT systems. If all you have is a single ERP, MES, everything system, you don't need us. But if you're doing a lot, you've got a lot of systems, we can help you out.
We should share that final slide because of my, could you?
Yes, I was going to say,
Jeff's
thanks
slide?
for holding us accountable
Yes.
and reminding us on the 2 questions that we need to ask, which is how long did this take?
Yep.
How much did it cost? The 2 remaining questions.
Yeah, so our standard pricing model is $17,500 per site per year. And so, you know, the primary demo was showing a single site. Aaron did show actually 3 sites with a cloud hosted. That would currently be $50,000 per year. So if you go to our website, you can find out our pricing. Took us 2 weeks, 2 people to build this out. We don't expect that the average manufacturer will be able to buy our software and build out that demo in two weeks with 2 people, but it is fast. We very much are focused on driving to value, selecting a use case, implementing that use case, taking an agile approach, and then broadening out to multiple use cases and multiple applications. And then you can see all of the problems. You know, I think fundamentally, as you can see from this list, we solved an IT problem. We solved, like, there's loads of manufacturing problems that are using that data, but what we solved was, I don't want all these point-to-point solutions, and how do I interact with these much more sophisticated applications than just, that don't have the ability to just publish an MQTT topic. We solved that problem for this case.
Yes, and I like the problems that you guys solved. All right, we'll go last question. Can you summarize how UNS, i3x, and MCP work together?
You can't define UNS because if you do, you kill it in the process. It's like jokes and frogs, right? UNS is hard. It's kind of, I think UNS is morphing. If you pay attention, it started out like just MQTT publishing to brokers, and it's changing. UNS and i3x are complementary. Like if you built UNS, like I would be very surprised if broker technologies didn't add i3x as an API to get data in that's more IT friendly to like SAP and things that don't speak MQTT natively. So those are not competing. MCP is agents only, right? So that is industrial agents. If they need to reach in and interact with industrial systems, you're exposing MCP and MCP tools. So that is related in the context that we are organizing data and making it more available through UNS, but it's a separate technology. Dark mode.
Can you show this laptop on the screen?
The joke is my team wanted to do this dark mode forever, and I was like, this is a waste of time. And then they snuck it into an alpha release, and it was the most loved feature. And that's just humbling product management. Like, my opinion, although interesting, is irrelevant. Yeah.
Well, I'll take the last one, which wasn't a question. It said, great job pivoting, guys.
Thank you.
Thanks,
Thanks everyone.
Awesome.
Thanks, Jeff.
Nice job.